Hey folks, welcome back. We will be starting Unit 2 now, factoring. It's one of our favorite units. I hope you guys enjoy it as well. Today's assignment will involve factoring using the GCF, difference of perfect squares, and then something new, sum or difference of perfect cubes. Now remember, when you factor, you haven't done too much of this since Algebra 1. You're going to rewrite your problem as an equivalent product. That means we're finding 2, 3 things that multiply to give you your answer. Now, let's see if this can work. I'm on the smartboard today. Here's our steps. The first thing we're going to work on is factoring using the greatest common factor. While I do the first problem, let's see if I can make this bigger. You guys can, if you remember me at all from Algebra 1, you know I like these things big. You can follow along with the steps. So the first thing we have to do is look at the number of terms. Here for part A, there are 2 terms. So we have to find the biggest number that divides into each one. Well, hopefully you know we can divide them both by 5. Oops, hold on a sec. I'm using the smartboard marker, not... Let's try this now. Hopefully now you can see what I'm writing. Yeah, I guess you can. It didn't like the smartboard marker. It wants this video making marker. So I can divide them both by 5. Now, there is no x term in this second section. In the 10, there's no x, so you can't take an x out. So long story short, your GCF is 5. Now you have your parentheses and you have to put the leftovers inside. You can bring down your plus sign if you want. And we're doing little division problems. 5x divided by 5 leaves you an x. 10 divided by 5 leaves you a 2. And that's how you factor with the GCF. Now, if you'd like to, you can pause this and try some problems on your own. Here we have 2x minus 6. We can take a 2 out of both terms, and you're left with x minus 3. Now, you don't have to show divide by 2. If it helps, do it. If not, then don't. Do what works for you for this section. Let's move over. Okay, this is a trinomial. Remember, a trinomial has 3 terms. You have to be able to take something out of each term. So I'm taking a 2 out of each term. And then my leftovers, we're left with x squared, and we have a minus 4x divided by 2 is 2x, and then 2 divided by 2 is 1. Hopefully, if you didn't remember GCF, that part is coming back to you. Now let's go to the next page. Take a look before we turn. This is talking about finding a product up here. Highlight that in yellow. Whoops. Oh, there we go. They want you to find a product. Remember, factoring is breaking something into 2 products. So when you see that, chances are you need to be factoring. So now let's come down here. So this says factor. We're doing the same exact thing. I'm going to erase this thing. I don't know if you guys can see it. I got an oval on my paper. We're doing the exact same thing, except the directions look a little bit different. So 20x minus 5x squared. We have 2 terms. We can take a 5 out of both. But now in this case, we have an x to the 1 and an x squared. So we have to take out the smallest x exponent that matches in each term, which would be x to the 1. So our GCF is 5x. Now when we put the leftovers, 20x divided by 5x gives you 4, minus 5 divided by 5 is 1. Subtract your exponents, so you're left with x to the 1 or just an x. Now give B and C a try, pause this, and then come back and check your work. I'm trying to move the screen. Here we go. So for letter B, it's a binomial. Find not too many colors to choose from. I'm going to divide both of these by 10. You can't take an x out because there's only x's in the first term. So I have a 10. I'm left with 3x squared minus 20 divided by 10 is 2. And there you have it. Part C is a trinomial. I can take a 2 out, but a bigger number, a greatest common factor would be 4. And there happens to be an x in each one of these terms. The smallest x exponent that matches is a 4x to the 1. 4x. That's our GCF, so you put the leftovers inside. 8 divided by 4 is 2. Subtract your exponents, 2x squared minus 3x to the 1. 20x divided by 4x is a positive 5. I'm sorry about sometimes when I write, it comes over graphically as connecting. That's it for GCF, except, of course, on Delta Math, they're going to give you some trickier problems. It's the way it is in algebra, right? Once you think something's easy, there's always the next problem. All right. So I'm going to do the first one, letter A, pause it, try letter B. You're doing the same exact thing. You find your terms. Remember, terms are separated by plus signs and minus signs. We have a 49 and a 21, so you take a 7 out. Now we have a lot of different letters. The first one I see is an x squared. That's in the second term over here, but there's nothing in the first term, so you can't take it out. That's just going to sit there. So now you look for the other ones that match. We have a y to the 7 and a y to the 4. Take out the smallest one that matches. That was a 4. That's a 4, badly written. And z to the 6 and z to the 4, I can take out a z to the 4 and a z to the 4. So my GCF is 7y to the 4. Try to keep that separate. Z to the 4. And then in parentheses, 49 divided by 7 is 7. Y to the 7 over y to the 4 is y to the 3. And then z to the 6 over z to the 4 is z squared. Now for the next term, 21 divided by 7 is 3. We still have our x squared. Y to the 4, that cancels out. It's a 1, and same with z to the 4. Now you don't have to put a 1 for a placeholder there because we've already got that 3. Now pause this, try letter B. I'm looking for a good green. There is no good green on this. Ugh, it's not very good either. So we have 9x to the 4, y to the 1, z squared, plus 33z to the 4. In these two terms, I can take out a 3. I can't take out a 9 because 9 doesn't go into 33. There is no x variable in the second term. There is no y variable in the second term. My smallest z variable is z squared. So that's our GCF, 3z squared. Now in leftovers, we have 3x to the 4, y to the 1, or just a y, and the z's cancel out. 33 divided by 3 is 11. Subtract your exponents, and you get z squared. You'll see sometimes when I do z's, I put little lines through them. The graphics on this are not that great, though. So what I want you to do now, you've watched this video. Hopefully it goes through on Delta Math. Do your Delta Math problems, and I'll meet you back here for some difference of perfect squares.